Okay, question 3. State what is meant by the internal energy of the system. Well, very nice. They are related. So the next question here, internal energy, delta U, or the U, is the sum of KE plus PE. So call this the sum of the potential and kinetic energy of the particles in the system due to the random motion of particles. Things to think about. Okay, so if you do statistics, you will understand that if I want to represent the data from a large distribution of things like human beings or gas particles, it's random, it's a distribution. Just like your test scores is also a distribution. All right, anyway, this is just, I don't know, definition part. Part B, use the first law of thermodynamics, or maybe the first part is to debate. First law of thermodynamics is change in internal energy is Q plus W. My dear friends, do not talk about KE, do not talk about PE in your subsequent explanation, okay? You will not get marks. All right. What happens to the internal energy of a spring when it is stretched at constant temperature within its elastic limit? Okay. So again, one statement about Q, one statement about W, one statement about delta U. Let's talk about Q first. If I stretch it, I don't think there's any thermal energy transfer. So no thermal energy transferred to the spring. Heating due to your sweaty palms doesn't count. Okay. Okay. When the spring is stretched, can I say the volume increase? And also the particle separation increases. So volume increases. So work done on the spring. So work is done. This is not gas on the spring to increase the particle separation and its potential energy. But the keyword here is work is done on the spring. How do I know work is done on the spring? Because the PE increases. Stretch elastic PE. All right, so this one is 0. This one is positive. Hence, internal energy, delta U, increases. 1 mark, 1 mark, 1 mark. B1, M1, A1. Okay. So work done, right? It doesn't always have to be gas expand, gas compress one, okay? Let me throw back to chapter, what chapter again? Chapter 5. Yeah, throw back to chapter 5, work energy power. Work done can be changed in PE, can be changed in KE, can be work done on or by gas. Of course, most of the time when we do thermodynamics, we expect the last one, but see. So this one, think about the potential energy of the particles, PE of particles, expressed in the bonds and the separation, and the kinetic energy of the particles expressed in the vibration. vibration, which is linked to temperature. Okay, so just a heads up, work done doesn't always have to be on or by the gas when you have this delta V. Okay, it can be the bonds, it can be vibration, it can also be expansion. So maybe this one we'll keep one side. Particle separation increase. Bond weakens. Okay, part 2. Water when it evaporates from a rain puddle on a hot day. On a hot day 就是 heat transfer to the water. I write Q first lah. Heat or thermal energy is transferred to the water on a hot day. Right, what about W? When water evaporates, it becomes gas, right? So it takes up a lot of space. Work is done by water expanding against atmosphere. So let's see. Positive Q, negative W, expanding now. And then delta U is Q plus W. If this is positive, but this is negative, how do I know whether my total effect is positive or negative? Which number will be bigger? Well, this one need to use a bit of common sense. When things evaporate on a hot day, evaporation, right? You feel colder on your skin. Like for example, if you take a shower or you sweat, the evaporation actually cools down your skin. So that means evaporation actually does a lot more work. The work done is actually much bigger than the heat transfer. Okay. So if work done is much more from the heat transfer, from the perspective of your skin, this means that the water carries more energy away from your body. So there is more thermal energy transfer. So need to compare. This one need a sidebar one. This one here. Compare Q and W. Like they level up already. So on a hot day, more thermal energy is transferred than work done by water. So because of this, delta U, internal energy of water increases. So the logic here is a reverse logic. Okay, if you don't use that, if you don't think from the perspective of if I sweat, my energy decrease, confirm the energy of the water increase because the water took away my energy. Okay. You could also think about the perspective of like when the water evaporates, it's going to expand against atmosphere. But it is not significant enough compared to the amount of thermal energy that we absorb on a hot day. So how do I know internal energy increases? Because, you know, delta U at the end of the day is KE plus P. So definitely the temperature of the water vapor is greater than the water itself. And this one also increased. So PE increased because bond breaks evaporation, right? KE increased because temperature of vapor is greater than water. So they both increase, right? Means internal energy increase. But I cannot use this to explain. This one is explanation using kinetic theory. But I can borrow this to think in my head, does the internal energy increase or decrease? If I use kinetic theory, and then I know delta U supposed to increase, and this one is positive, meaning Q, the positive Q, must be bigger than the negative W. Positive delta U. So Q greater than W. And then I write down this statement. So this is the difficult part. You may encounter a scenario that you've never seen before, and you may need to attack the question from both sides. But when you write down your explanation, you only explain based on the perspective that they want. This one is not asked. Okay, all of this is B marks. I guess they at least have the awareness that this is not as straightforward as we think. This is B. Okay, I want to read the examiner report with you. Okay, lie. In both parts of this question, there was a widespread misunderstanding of the terms involved in thermodynamics. So candidate think that the internal energy, thermal energy, and work are entities possessed by the system. So not the same thing. Delta U, Q, and W, no. Awareness will rare that it is internal energy that is possessed by the system, and the transfer of thermal energy and doing work simply ways which thermal internal energy may be changed. Okay, so this is what they are saying. Delta U, you can write increase, decrease, because it is something that is possessed by the system. But how do you know whether delta U increase or decrease? You need to check in with Q. You need to check in with W. That's why delta U is Q plus W. So for Q, you need to use the language transfer of thermal energy. Transfer into or out of the system. Okay, my friends. So don't just say internal energy increase. I think when I was marking your trial paper, I was also quite strict about this. You never explain the direction of energy transfer. You just say increase. Increase why? Increase how? Increase from what? Right? And then if you cannot say W increase, decrease, you have to use the language work done on the gas system or work done by the gas. Okay? Because both of these are ways in which internal energy may be changed. So do not use the word increase, decrease. Increase, decrease is only exist as a deduction after you consider Q and consider W. Then you deduce. But you cannot say Q increase, decrease, positive or negative. So positive does not mean increase, transfer into the system. Negative does not mean decrease, transfer out of the system. Transfer. Okay. W, work done on the gas or work done by the gas. If work is done on the gas, then it's positive W. Work done by the gas, negative W. Double check your sign convention. Okay. If it's work done on the gas, volume decrease. This one, volume increase, expand. Okay, it is common for candidates to write about work and thermal energy increasing, decreasing, or remaining constant. And it was clear that the candidates has a poor understanding of the law. Roasted, so sad. It is also important to stress to candidates that explanation questions like this require accurate use of technical terminology. Credit is not awarded for the use of undefined symbol. Do you hear that? Those of you who I deduct marks, those of you who use symbol without actually writing the name. So in my head, right, when I answer this question, I'm not even going to write this. This is for me one. Maybe I write in pencil, then I come back, I rub off one. So the examiner is going to ignore any symbol that is not defined in the question unless you go and define it and just read your sentences. So cannot say no Q transfer to the spring. Cannot. Don't be like that. Okay? Don't be like that. Because Q for you may not be Q for the examiner. It may be something else. Okay. So responses should be rooted in the context of the question. In the case of a spring and a puddle of water, rather than undefined gas or system. Okay? So you see, I didn't use system. I used the word spring. And then I didn't use system. I used water, or maybe I should have used water. So I always write back the question for them. If the question calls it water, I will call it water. If the question call it system, I will call it system. That's why if you look at the way I do it, I will keep scrolling back. This is pretty important because they care about this. They want to see whether you have a scientific understanding and the ability to draw from the scientific explanation. Okay, anyway, let's look at the question-specific explanation. For B1, it was common for weaker candidates to think of spring as a gas. This is GG. So physics really cannot just memorize and spam application one. It would be just it. Unless you're very lucky, all the question is very normal question, which is never the case. You look at the questions we've tried today. Okay, so concluding that if it expands, it must be doing work against atmosphere. Very, very sad. Candidate that realize that work has to be done on the spring to stretch it were usually able to conclude that internal energy increases. Okay, so this one requires you to also understand that if let's say you cannot brain whether the work is done on the spring or by the spring, you could think about the perspective of the particles. The particles are now stretched further apart. The potential energy of the particle increase. So if potential energy of the particle increase, work is done on the particle so that the internal energy increase. Okay. And part two, candidates that understood the physics of evaporation, common sense, were usually able to state that water does work against atmosphere. Okay, so we want this, water doing work again, work done by the water against atmosphere. Did I write that? Work done by water, correct, against atmosphere. Evaporates and thermal energy is supplied to the water by the sun. For the award of credit, the direction of energy transfer needs to be clear. So once again, they emphasize this 2 times for the same question part. Don't just write increase, decrease. If there's energy transfer, where is it transferred to? Okay. Full credit required reasoning about how these 2 interactions interact to result in an increase in internal energy. So I need to compare Q and W. This proved to be challenging, but nevertheless, quite accessible means quite answerable to the strongest candidate. So these are what I like to call a filter question. I want to filter out the questions from the weaker students. Okay. Okay, so that's it. So whenever you encounter a difficult question, or rather for me, this is what I'll do as a student. When I do a paper, especially the recent year one, I will always look at the examiner report because I want to learn from other people's mistakes so I don't make them. When you play a game, right? Let's say you play a station game. And then do you want to be the first team to try the stations? No, I'm going to let other people try first because I want to see them make mistakes, or I want to see whether they have good strategy and then I want to copy it. Okay, I don't have any ego one. I'm very happy to learn from others' mistakes. I'm very happy to adopt from other people's good technique. Okay? Because you adopt, you edit, you refine. That's how science works. Nobody start from zero. We learn from someone who learn from someone who learn from someone. So learn from people who answer this paper and GG. Okay. And the examiner will also tell you what they are looking for. This includes proper scientific terminology. Don't just increase, decrease anymore, especially for this law. And do not use symbols. Okay, that's it for this question.